This is a lab on reading resistance using the 4 color codes. So I'm going to give you just the basics first, the color codes, then you do the practice. This is a quick summary. So for example, let's say that we have this resistance here. We have different colors. So let's red, blue. Let's see, we have green, and on the other side, the end, a silver color. So the question is, how do you read this? So this is divided in number 1, number 2, number 3, and number 4. Number 1 is giving us the first digit on color code. The second number is, of course, the second digit. The third number tells us how many zeros do we have to multiply or to add. And the last one is number 4. This is a tolerance. So tolerance is about the precision, how many percent, plus or minus percent of the total value is the actual. Now the main key is, how do you read it? Here's the key. What you have to do is look at the gap here. There's a gap here. There is something missing in the middle here. And that will tell us that usually there is one last stripe down here. This is for the number 4, the tolerance. So when we look at the number, you start from, check the gap. Where do you see the gap here? So your number 1 is on the right hand side, then followed by number 2, followed by number 3. And the other color on the other side is the tolerance. Okay, so let's read this one. We have first here red. Red is on the color side, red is 2. So we write 2. Then we have a blue. So the blue color is corresponding to digit 6. So you write 6. The next one, number 3, is the number of zeros. How many zeros would we have? Green is 5, 5 zeros, and then the units ohms. So that is a 2,600,000 ohms, and we can use the prefixes. So divided by 1,000, then we can get the kilo ohms. So that would be 2,600 kilo ohms. We can still divide by another 1,000, then we can get, in this case, 2.6 mega ohms, which is even practical. Okay, so we add the tolerance. So since we have a silver, that's 10% tolerance. So in other words, if I go back to the colors here, to the units of ohms here, with a few zeros. So what's the meaning of the tolerance? We can write that the actual value is 2,660 kilo ohms, and the maximum amount is, in this case, if we add those two up, so that would be 2,860 kilo ohms. We have a 2.86 mega ohms, if you will, or just the 2,860. That's the maximum amount. If you subtract, then we will get the minimum value is. So that's the meaning of the tolerance. So we just use the average value. If there is nothing, so again about the tolerance, usually with the 4 color codes, if you have a silver, tolerance is 10%. If you have a gold, it's 5%. And if there is nothing, there is none, just the 3 colors, and that's about the 20% average. There are also a few very accurate, with more accuracy, like red, blue, but we will be focusing on those 3 different tolerance colors. Okay, so let's do the practice from the lab experiment. So we have R1, R2, and R3. So the R1 was like this. Draw the colors, red, and another red. Then the last part here is a silver. So again, the key is how do you read the color in order. So the first color would be, the gap is right there. So you have to go to the other side with more colors. Number 1, number 2, number 3, and this will be the tolerance, number 4. So blue means 6, red 2, followed by red, so that means you have 2 zeros. So this is the actual value, and we have a plus or minus 10% tolerance. So I can do the calculation of the tolerance. The second one is we have green followed by brown. The next one is black here. The gap is right there. So the word of color is 1, 2, 3, and the tolerance is the 10% here again. Let's look at the last one here. Orange, violet, red. Orange is for 3, is for 7. Red means we have 2 zeros. Red is 2 zeros. And now there is no fin on this side. There is none here. So if you do not have silver, if you do not have gold, any of the colors, that there is none. So that means the tolerance is 20%. So for example, how do we add this to calculate the margin? So if we set the minimum value and the maximum value of the resistance in this case, so we just add the 2%. So 2%, 10%, 10% of this is 260. So the maximum value is 6860 ohms, and the minimum value, you subtract this 6200 minus 620. That gives us 5. It should be 5 here. 5580 ohms. Minimum value, maximum value. The average here is, I'm going to use that for the calculations of the circuit in electric circuit. For the 51 here, the 10%, 0.5. So if you subtract 51 minus 0.5, then we have 50.5 ohms is the minimum value. Then 51.5 ohms is the maximum value, and so on and so forth. So if this one is the number 3 here is a big one. There's a big gap with a 20% margin. So if we calculate, for example, if you calculate the minimum value, that would be 2,960 ohms. And the maximum value, 4,400 ohms. So what you do is, again, if you want to calculate the max, you add the 20% in this case. If you need the min, you subtract. So 20%, the tolerance for this one is, you add for 5%, you subtract of 10%, 10%. Okay, so next step, we're talking about the resistance equivalent. Start with just giving you again the rules. If you have two resistors, for example, so let's say R1 and R2, if it is in a series, I write the dash to express something in series. So if it is in series, the R equivalent is just you add those two up. So take R1, add R2, The key is that you need to use the same units, otherwise you're going to do some different errors. If it is in parallels, I will write it this way: R1 parallel R2. What is the R equivalent in this case? The R equivalent is you take the inverse of the sum of the inverse. 80% of the time errors made by students is about the calculations here. You just apply these rules, and that will allow you to calculate any types of combinations. Sometimes it takes time, sometimes it's easy to do, but what you have to do is apply the rules. Okay, so let's do the practice. What do we have in this case? What is given? There are 8 questions here. What I'm gonna do is let's begin with the very simple one. So question number 1, if you have R1 and so I'm gonna write it this way so you understand what is the meaning of this. R1 and R2 in series. So that's the very simple. Take R1, make sure that you use the same unit. You add R2, then you get your numerical values. R equivalent, the R equivalent, that's a question. So the R equivalent is add those two up, 6,251 ohms. Very simple. Number 2, you do this in parallels. So I will express it this way. If you have to do this in parallels, what is the R equivalent in this case? So again, if it is in parallel, you take the inverse of the sum of the inverse. So be careful again when you do your calculations. 6200 plus 1/5(1). If we do the calculation, right calculation, you're going to end up with 50.6 ohms. So for example, let me show you those two. What did you get for these two, 6200? So that is giving you, for example, this 0.019769. Then you take the inverse of this, then you end up with that number here. So be careful when you do the calculation. Let's see the number 4. Do number 4 in this case. Question number 4 is if you have R1 and R3 in parallel. So it's the same calculation. And when you do this calculation, you would end up with 2317 ohms. Just check that out. Okay, number 6. I'm gonna solve number 6 and probably number 7. I'll let you do the rest. So number 6, we have R1 parallel with R2 in parallel with R3. So we have 3 resistors in parallel. And same thing, what do you have to do to get the equivalent? Take the inverse of the sum of the inverse, 1/370. And that will give you 49.9 ohms. The last question, number 7. This is a combination. So what we do is exactly the same thing. So in this case, we have R1 in parallel with R3. And that would be in series with R2. So what you do is just to do it one at a time. Do it one at a time. So for example, we have calculated this one here, which is right there. So I just add the 2317, then add the R2, which is 51 ohms. Then you get the 2368 ohms. That's the R equivalent. Okay, so I let you do the solving the other ones and should be able to to do the equivalent.